Hey everybody! How we doing? Happy Friday to you. Hopefully yesterday the product rule and the power rule went pretty well. Today we're going to finish the other part of that section 3.3. I know it's a short day, so this is going to be a shorter lesson than it was the last couple days. We're going to look at something called the quotient rule, which is a way to differentiate quotients. Okay? So kind of along the same line of difficulty as yesterday. Just some problems that involve division instead of multiplication. Okay, so I'm going to get right into it. Hopefully everything's going well with your homework and you guys are helping each other out during class and answering each other's questions at the beginning of the class. And I'll be back soon. Hopefully sooner than later. Okay. All right, so keep plugging away. All right, so here's the deal for today. I'm going to go through a similar example to the one I did last class. Here's a function f of x, 3x to the fifth, and another function g of x, which we'll say is 2x cubed. Okay? Now I'm using very simple functions to make a point about why you can't just divide two derivatives to find the derivative of the quotient. Okay? So let's say we have some function h of x, which we define to be f of x divided by g of x. Okay, so we want to find the derivative of h of x, let's say. Well, one person might say, well, all you have to do is take the derivative of f and the derivative of g and divide them. Well, let's try that. Let's see if that works. Now this is just a guess, so I'm putting a question mark above the equals because I'm not sure this works. We have to test it. So the derivative of f would be 15x to the fourth using the power rule. And the derivative of g would be 6x squared using the power rule. Which, if we simplify that, that simplifies down to 5/2 x squared. Okay? The question is that really the derivative? Unfortunately, it's not. I wish it was that easy, and it's not quite that easy. So let me show you why it's not. Okay? If we actually divide the two functions, h of x is f of x divided by g of x. So it's 3x to the fifth divided by the g of x, which was 2x cubed. Well, we could actually divide this before we do the derivative. If I divide these terms, it's going to be 3/2 x squared, since I subtract the exponents. Well, if that's what h of x is, if I reduce it to a power function, then the derivative is easy. I just use the power rule. So h prime of x, we know would be 2 times 3/2 would be 3 times x, lower the power by 1. So that's the true derivative. So that's right, based on facts we know. We know that dividing these functions gives us this. That's just the exponent rule. And we know that the power rule is right. So 3x is the correct derivative. Notice that that's not what we got before. So this 5/2 x squared, that was wrong. Okay? So again, the point is that when you're differentiating a quotient or a fraction, you can't just take the derivative of the top divided by the derivative of the bottom. Doesn't work. Wish it did. Doesn't. Okay? So just like the product rule, there's another rule for quotients. Guess what it's called? Quotient rule. Right? Let me show you the formula for that. Quotient rule looks like this. The derivative of, let's say, f of x divided by g of x turns out to be g of x times f prime of x minus f of x times g prime of x all over g of x quantity squared. Yeah, no, that's not the prettiest formula ever. The product rule is bad enough. Quotient rule, it's even worse. But basically, if you think about a quotient as being a top function divided by a bottom function, we've got the bottom times the derivative of the top, minus the top times the derivative of the bottom, all over the bottom function squared. Okay, so that's the rule. I'll show you how to use it. It's not as bad as it looks, but this is a formula that you want to make sure you write down in your notes, and you get a lot of repetition with it, so before no time you'll have memorized it without even trying to. Another version of this that you'll see is that the derivative with respect to x of u over v, so instead of using f of x and g of x, we use u and v. That's the bottom, v times the derivative of the top, u prime, minus the top, u times the derivative of the bottom, which is v, all over the bottom squared. Okay. So that formula means the exact same thing as the other formula. So you'll see both of those in action. Okay. Now let me try to show you how this works. Again, going back to that last example. So remember I had my h of x function, which was, let's see if I remember, 3x to the fifth divided by 2x cubed. Let's use the quotient rule on this problem. Now you would never use the quotient rule in this problem because it's much easier just to divide these terms and then use the power rule. But I just want to illustrate a point here that the quotient rule works. Okay. So to find the derivative using the quotient rule with this simple function, you take the bottom function, which is 2x cubed, times the derivative of the top, 15x to the fourth, minus the top function, 3x to the fifth, times the derivative of the bottom, which is 6x squared. All over the denominator squared, which is 2x cubed squared. Okay, so now I'm just going to do some algebra to simplify this and hopefully show that it's equal to 3x, like we got in the other problem. All right, so multiply here first. That would be 30x to the seventh. Multiply here, 18x to the seventh. On the bottom, if I square that, I have to square the 2 and square the x cubed, so it's going to be 4x to the sixth. Remember, a power to a power, you multiply the exponents. 30 minus 18 is 12x to the seventh over 4x to the sixth. 12 divided by 4 is 3. X to the seventh over x to the sixth is x. Whoop-de-doo. So again, it was a lot easier to do the other way, but this shows you that the quotient rule actually does work. Now, the quotient rule actually is necessary because there's problems that you can't do in other ways. So let me show you an example of such a function.